This is the automation setup of the focus stacking rail. The stepper motor drives the focus knob via some cogs. On the other side of the focus block, the distance travelled by the camera platform is marked in microns. The Big Easy driver was bought from SparkFun, and a tutorial by the manufacturer can be seen at the URL on screen. We use the Big Easy driver because it gives much finer control over the rotation of the stepper motor. On the bottom left, we have the connectors for the power cable that drives the stepper motor. Right of this, we have the connectors for the wires of the stepper motor. The wires can be seen below and are connected in pairs to the B connections on the left and the A connections on the right. The colour of the wires that are connected in pairs depends on the wiring of the motor, and we will come back to that later. Near the centre of the Big Easy driver is a potentiometer marked C here, and this may need to be adjusted using a small screwdriver. This adjusts the current reaching the motor, and turning the potentiometer gently until the sweet spot is found will cause the motor to turn smoothly. At the top left we can see the DIR connector, the step connector and the ground connector, and these are connected respectively to digital 3, digital 2 and the ground connector of the Arduino, which we will look at in a minute. The step pin is a logic input. Any transition on the step pin from low to high triggers the motor to step forward one step. The direction and size of the step is controlled in this setup by the DIR pin. The DIR pin is also a logic input. The pin determines the direction of the motor rotation. Changes in state only take effect when the step pin changes state. These are all the pins that we need to use in the Big Easy driver. This is the Arduino computer, which runs the computer program to control the stepper motor via the Big Easy driver. The wires from the Big Easy driver are inserted into the slots at the back and at the front, shown here. You can see the step and DIR wires coming into the digital 2 and digital 3 sockets respectively. Moving focus to the front of the Arduino, we can see the ground wire from the Big Easy driver coming into the ground slot. We now return to the Big Easy driver for a quick look at the stepper motor wires before going on to find out which stepper motor wires go into which of the A and B slots. The SparkFun documentation on this says, for a 4-wire motor, take one wire and check its resistance against each of the 3 remaining wires. Whichever wire shows the lowest resistance against the first wire is the pair mate. The remaining 2 wires should show similar resistance between the 2 of them. The ohm meter shown here shows the kind of response that you can expect when testing the resistance. Having found the correct pairings, one pair are connected to the A connections on the Big Easy driver and the other 2 to the B connections. For a 6-wire motor, please refer to the SparkFun documentation listed previously. The remote control allows the camera shutter to be triggered automatically between movements of the focus rail. It's also programmed from the Arduino, and so we will look at the wiring for this setup now. In order for this mechanism to work, the camera must be put on the setting usually used for the manufacturer's own infrared remote control. We now see the wiring to the Arduino, where the 2 wires are connected into digital 13 and ground sockets shown here on the left. In order to make the remote control for this setup, we bought a third-party infrared remote control and stripped off the outer casing. At one end is the bulb, and then here we can see the purple wire leading from the digital 13 socket and the white wire leading from the ground socket. They are fixed on using a hot glue gun. We have now covered all the details of the automation setup.